Right. Thanks for coming. My name's Andy Waafa. I work for ARM as Principal Engineer for Open Source. What does that mean? Yes, in a nutshell. I am concerned with enabling the open source community to be able to leverage the ARM architecture as best as possible. So, anybody able to tell me who that is? Thank you. You are old. So, who are we? You know, who is ARM? Well, we're an IP company, so we come up with architectural designs focused primarily on CPU and GPU technology. We don't actually make anything. We do designs, and then we license those designs to partners, so Samsung, Qualcomm, etc., etc. We're a global company based in Cambridge in the UK, although we are relatively small-sized, considering the reach that we have. Somewhat oldish. Started off it dates back to 1990 with Acorn Computers in the UK. It was spun out into Advanced RISC Machines, which then turned into ARM. And ARM doesn't actually mean anything anymore. It's just ARM. One question, how many people here have mobile phone, SD card, hard drives? Anybody? Cars, motorbikes. You'll find an ARM design chipset in all of those. Or a ARM designed processor of some sort, whether it be a microcontroller, application processor. Recently ARM have shipped, the ARM partner ecosystem has shipped over 50 billion processors. So it's not a small number. So that's who we are. Now, what? What do we do with open source? How do we leverage the open source communities? How can the open source communities leverage ARM? So if we take the design for a CPU or GPU or something like that, we can use the analogy of a house. So you've got foundations, frame, windows, doors, etc. Our silicon partners like Samsung, Qualcomm, MediaTek, AMD, etc., they're looking after the frame. Communities, companies, ISVs, etc., they're going to be looking after the doors, windows, roof, etc. Where ARM comes in is that small grey bit at the bottom, the foundation. So to be able to have a good house, successful, long-standing, you need solid foundations. So our focus is on making sure that the core components to enable an operating system to work are there. So in the foundations, from our perspective, it includes things like firmware, platform description, kernel, and toolchain, and things like that. So from firmware and platform description, as you can see there, you've got ACPI. We are part of the ACPI consortium, if you will. It's an ongoing task. It's focused on the upcoming ARM v8 64-bit platform, which we should be seeing very soon. It's still a long way from being complete. some would say that it's not quite complete on x86 yet, but we're trying to ensure that we implement as much of the specifications as possible and ensure we do it right from the start. UEFI, again, we're part of the UEFI consortium, which ACPI falls under now, and we're trying to ensure that our platforms are standard. There's no fragmentation, there's a standard way of booting things. People that are coming from the x86 world know how systems boot, they're used to UEFI. Secure boot with UEFI as well is kind of critical in a lot of places now. U-boot is predominantly used on the existing ARMv7 platforms. Our preference for V8 is to use UEFI. It's not mandatory, but it's the recommendation. So we are working with the U-boot community to ensure that some of the core level components actually work. We're not that active within U-boot anymore, because U-boot's very well established, and a lot of our partners do a lot of the work as well. Trusted firmware falls into the ARMv8 bucket. That's a project that we've started to ensure that the trusted execution environment is available and works and is uniform and standard again across all platforms. And then there's device tree, which is the current platform description method that's used on ARMv7, and it will most likely be used for ARMv8 for the initial batch, and then with a transitional period over to ACPI as the platform description. It's not a quick and easy task of ensuring that device tree is clean, so it's a long process, and it's taken us 3 years to get to the state that we're in, where it's relatively uniform and partners understand how their platform should be described. So moving on from the firmware, come on to kernel. Most of our open source focus is on Linux, so it's where a lot of our efforts there. So what do we do with the kernel? We enable the ARM IP blocks upstream, so when it comes to bringing the device up, etc., you should be able to just take mainline and it should, in theory, work. I'm not going to say it will, but that's the plan. And we also work on connecting our IP blocks with third-party components. So ACPI is a prime example. It's not something that ARM has developed, but it needs to talk to the kernel, and it needs to talk to aspects where we have enabled components within the kernel. And then there's ensuring that our community and partners can still work if they come up against bugs, issues, need some guidance, advice. We're there to help try and steer them in the right direction. And then there's always the whole performance testing, regressions, optimizations, improving what's up there already. As part of our kernel work, we also hold maintainership in multiple areas. So we have the maintainership for ARMv8 and also for KVM on ARMv8, as well as being co-maintainers for KVM and ARMv7. Development tools, well, there's multiple tool chains available. Which one should we pick? Why pick one? GCC is the incumbent, So naturally we're going to ensure that we support GCC. LLVM is growing in usage, especially within the graphics world. So our GPU guys, a lot of stuff interacts with LLVM. We have been very active within the LLVM community, helping foster it. We were drivers behind the LLVM European conference for the last few years. That's now transitioning into its own body, which is great to see, and the community is taking over the steerage of the LLVM European conference. So, and not only that, LLVM is now, with the new ARM compiler 6, is the default backend. So we not only support the community, we're actually using a lot of the output there as well. So within development tools, we're doing pretty much the same sort of thing as we do with the kernel. So it's all, enabling 3 families of ARM processors. We've got the A-class application processors, which you'll see in phones, tablets, media devices, etc. We've got the M-class, which is the microcontrollers, which is powering a lot of embedded class of products. And then the R-class is real-time family, which you'll see in hard drives and other devices like that. So we're ensuring the correctness of each compiler, ensuring that it generates the right code. Again, performance regression testing, a key item. As with the kernel, we hold maintainership roles, so they include the ARM backends for the various compilers, and also supporting the community through various means. So that's the foundation. Where do we go on from there? The open source world is very wide and varied. So now that the foundation has been laid, we can look at enabling other components that would then build on top of that. So looking at different application frameworks, ensuring that they're all working correctly, they're performant in comparison to alternative architectures. But it's not just application frameworks, it's also alternative operating systems. So we're starting to work up the FreeBSD community, or work up with the FreeBSD community to enable FreeBSD on ARM. The community there has done a lot of work, but they still need some help and some guidance on how to move things forward. And working on Android to ensure that it, again, is performant and is supporting our architectures. ARM ported Google's V8 JavaScript engine to ARM V8. That's now upstream as of version 3.25. So it's all up there to ensure that, again, the web technologies that leverage JavaScript and V8 can actually perform well. So that's us working with external projects. We also have some of our own projects which are open source. NE10 is one of the bigger ones. We've got Vixel, and as I previously mentioned, Trusted Firmware. NE10 is an open source library that helps to maximize the utilization of the Neon SIMD engine. The engine itself has been quite useful for and flexible at doing a lot of mathematical transactions and is quite adept at web work, so Canvas and things like that. Vixel is a dynamic code generation tool aimed primarily at JITs, so Python, Mono, etc. could benefit from utilizing Vixel for porting to ARMv8. So ARM's been historically seen as an embedded processor architecture. So embedded is evolving, and Internet of Things is the next big thing. So with the Internet of Things, ARM have created a project called mbed, working with a lot of our silicon partners. It's a cross-platform embedded system based on the M-class family. Everything's done through a browser. A lot of the code's on GitHub. So the intention is you write once for the mbed platform, and it will run across a wide range of platforms from our partners, from NXP, Freescale, SE, Micro. You can get an mbed certified platform for about €10. That includes your sensors, could have temperature sensor, have Wi-Fi on there. People have started doing projects like a gardening monitoring station, check pH levels, check water, all those sort of things, and it reports back to the browser, or back to web. You can monitor it from your phone, desktop, etc. So, as I said, it's a components library, so you write once and it's there, available, can be reused from one platform to the other, talking to web services, large scale things. There's, as a use case scenario, for instance, you could have a local authority want to try and cut down their electricity on street lighting. Currently, most of the time, street lighting comes on based on a timer. Not necessarily the most efficient way of lighting. Be much better if it was more responsive to and safer for users if it responded to light circumstances. So if it's very cloudy, etc., it needs to come on earlier. It's a nice summer's day, so it's light later. It adjusts dynamically. It reports its usage back to back-end server, and you can monitor it there from an enterprise perspective. As with most things with open source, there's a legal component. Licensing is much more at the forefront now of a lot of projects. It's not something that you go, well, I'm not a lawyer, nah, I'll just pick that license, it kind of sounds nice. So, with regards to legal and licensing, when it comes to a project that ARM creates, like NE10, Vixel, etc., we prefer more permissive licenses. For us, open sourcing a project isn't a means to go, well, we've kind of got the most out of that, whatever, there you go, you might find it useful, whoever. We open source projects to try and build up a community around that project. We want to get people involved. A lot of our partners are quite twitchy when it comes to more copyleft style licensing, because they have a lot of proprietary code, etc. So to try and get them involved within those projects, having a permissive license like BSD or Apache, etc., is a way of getting them to get involved into those projects. So as an example, as you can see there, Trusted Firmware NE10 VXL are BSD Clause 3, and mbeds Apache 2 licensed. When it comes to working with external projects, we prefer OSI approved licenses. If it's not an OSI approved license, then at the very least it's a well-known, well-understood license by the community. Our legal team does a lot of collaboration with internal groups and a lot of education within internal groups when it comes to open source usage, licensing, etc., and provides regular guidance and workshops on how to work properly and ensure that as an IP company we are still protected and there's no potential infringement, etc. Our legal department is actually quite knowledgeable with regards to open source, and they're quite comfortable with working within the open source community. We're involved in numerous Linux Foundation based legal initiatives, SPDX being one of them. We're co-chair of the SPDX initiative. Having an open source savvy legal department has been acknowledged by the Linux Foundation as something that needs to grow. There's not enough companies that have a legal department that understands the open source way of working. So we're quite lucky in that respect, and we try and leverage that advantage to the best of our use. So as a company, just like SUSE and other corporates, we are trying to be active within the open source community, and part of that activity involves membership of numerous foundations, work groups, etc. So just as an example of some of the groups that we're involved in, Linux Foundation, we're on the Zen Advisory Board, the Zen Hypervisor, we're a member of the Open Virtual Alliance, the UEFI committee, and also a member of Linaro. So what is Linaro? I think most people know Linux Foundation. Zen Project's a subset of Linux Foundation. UEFI is fairly well known. Who's Linaro? Well, Linaro is a non-profit engineering organisation based in the UK, and their goals are there for you to read. I'm not going to reiterate each bullet point, but the intention there is for us to grow with our partners and ensure that ARM is a good open source citizen. Our code is upstream, our code works, it's comparable to other architectures when it comes to Linux support. So there's lots of aspects there that need work. As I mentioned earlier, ARM's a small company. We're built upon our partnership with our ecosystem. So having Linaro as an independent body, if you will, able to bring all those competitors together to improve things. So some of the members of Linaro, you can see there, it ranges from CPU vendors to OEMs to web services companies, etc. There's a wide variety of people involved there. And that variety actually helps bring in knowledge from different areas to improve the state of affairs. So ARM, as many people, is recruiting. We've got over 220 vacancies. If you go to arm.com/careers, you can see the full list. We've got openings from the US on the West Coast to Japan in the East and most points in between. We've got key offices in San Jose and Austin in the US. We also have an office in Seattle. Our head office is in Cambridge. We've got other sites within the UK, Maidenhead, Sheffield being two of them. We've got a couple of offices in France. We've got Germany, you name it. We are in a lot of places. So if you want to get involved, by all means, please do put my name down. There may be a nice incentive there. It should be. It was working 2 years ago. Yes, use LibreOffice when you're applying. We also have internships available, and we've got a fairly good and successful graduate program. So if you know any students that are looking at getting into open source professionally, then please tell them to apply. So with that, trying to make up a bit of time, any questions? Mr. Meeks?
How small a company can you claim to be when you have 4,000 employees and 228 job?
In comparison to our reach, if you will, and our penetration within the market, I think 3,000 is fairly small considering 50 billion units have been shipped. We're in over 95% of mobile phones, etc., etc. And when you look at some of our partners, for instance, take Qualcomm as an example, we are significantly smaller. And if you take some of our competitors that work in processors and GPUs, again, we are much smaller. So it's a relative figure.
I didn't say anything, and I said several times, don't bother, bring me the microphone.
Any other questions?
You mentioned compilers. We are working, of course, not on ARMv8, not such new stuff, some existing stuff, ARMv7. And our compiler reads something like MeGo 2010 or so. And well, being a small project, there's no time to investigate a better one, and it's a huge amount of packages, and nobody wants to take the risk to build everything again. Well, ops will build it, but then how will it work and who will test it? How do we pick a new compiler? If we take the newest? Well, first, if we take the newest Linaro one, for example, will it work? Will everything compiled that compiled with the old one? And will we see a difference? Maybe these two questions.
So, yes, you should be able to take the latest Linaro compiler, and it shouldn't break any ARMv7 because it's still tested against ARM v7, because v7 is still the existing architecture. It's the dominant one, so it shouldn't break anything. I can't guarantee that, because you do get breakages from time to time. For instance, moving from GCC 4.7 to 4.8, there were some breakages. So it should work, and it does get tested. With regards to your second question of should you see a difference, I would like to say yes. I can't honestly guarantee you would, but we do feed in optimization improvements, etc. And especially if you're going to be using the Linaro compiler, it is running very close to TIP. So it should have the latest and greatest with each release that gets backported and tested. So yeah, I would recommend using compiler from Linaro if you don't want to be running TIP, or if you don't have, for instance, if you're running on v7, we always recommend to use the latest release, so 4.8, 3 I think is available. So yeah.
Thank you.
Any other question? Yeah.
Hello. Is ARM making any effort in making some modules? Let's say, for example, if I would like to run an Linux on my mobile phone, which has an ARM processor, but usually there is a lot of problems with proprietary modules inside, and I can basically boot it, but I cannot actually do anything with it. Is ARM doing anything in that direction, maybe trying to establish some kind of, let's say, a board or something to make modules more standard, more open?
We work with a lot of our silicon partners to try and we try and advise them on certain aspects, but we can't tell them what they must and mustn't do, because there's always a business component to it. They're in it to make money, much the same way we are, in all honesty. But in theory, with ARM v8, if that makes it into mobile phones, etc., you should be able to get most of the way, but you're going to be looking at components like Bluetooth, wireless, etc., where we don't have any control over. So it's one of those situations where we want to help, but our hands are somewhat tied. Yes. Pick and choose, really, at the end of the day, if you're looking at building a hardware. If you're looking at building a mobile platform, for instance, then you can select components that are more open, etc. Some vendors, whilst not being open source, they do have binary blobs available. Others don't even have the binaries available for you to use. And there are numerous efforts within the community to open source certain aspects of different silicon vendors.
Say again. Yeah, so I think things are improving slowly. So you can buy hardware that's fairly open now. If you get a Plays Live board, that's everything on there you can get at. And it's got a Mali GPU, which is largely reverse engineered, although you can't actually get an X driver to install today yet, because, I don't know, people. And the kernel story on there has been a bit of a mess, but again, that's working its way through. I think 3.15 should be pretty good and have most of the things working. And that's supposed to be what's going into a KDE Plasma tablet thing real soon now, but we're all still waiting for that. You know, and a Nexus is good hardware, except for the GPU in it, which is awful. You can't do anything. But increasingly, the current GPU versions have kernel shims, so you don't have to have the exact same kernel version that the phone shipped with. You can upgrade things, and stuff will still work. So yeah, you know, if you pick your hardware reasonably carefully, you can do most of what you wanted to do. But the situation is still embarrassing in many ways.
Anything else? Going once? Going twice? So, thank you very much.